Okay, so number 11 here uh, is tough, and the same goes for number 12 down below. Very difficult, but if you can work out what they're asking you to do, it's theoretically, I think, within your ability. So it says that because our scaled image ends up looking blocky, which is true, one way of reducing it is to smooth it out, essentially, which is take the values of the pixels surrounding it, so the pixel above it, below it, to the left and to the right, and instead of having a new pixel equal to that old pixel, instead have it set equal to the average of the red, green, and blue of those pixels. So take the reds of the pixels surrounding it, average that, take the greens, average that, take the blues, average that, and then create a new pixel without those averages as the values. So that's a lot. And I had a hard time getting this running. I ended up having to actually import the sys module so that I could raise the execution limit to a much higher execution limit because it was just timing out every time I ran it. So not great, right? But that is where we are. So I don't recommend if you're on a slower laptop trying to do this. It will probably lock up your browser window for several minutes if you try to do it. But let me walk you through the code that I've written here. So this builds on the doubling code that we already did, and so in fact all of this part up here is just the exact same code. All it is creating a doubled version of the image, because obviously we don't want to just smooth the basic image, we want to smooth the doubled version of it. So the same way that earlier we took the grayscale and then took the grayscale and turned it into black and white, we're doing the same thing here where we're doubling it and then smoothing it. So this is all the same code that we had in the double function. Then we take it so that we get the width and the height of that doubled picture, and then we create a new image, a smooth image, that is the width and height of the doubled picture, and then we do another nested for loop where we go through every pixel in the doubled picture except for the edges, which is what this range function is doing. It's doing every pixel except the pixels around the far edges. So every pixel except for the pixels along the far left, the far right, the bottom, and the top. So that's what these for loops that I've rewritten here do. And then it's going to grab the 4 pixels surrounding our current pixel. So it's going to grab the pixel on doubled image at the current column -1 in the current row, which is the pixel to the left. It's going to grab the pixel to the right, which is at this location, the pixel above it, which is at this location, and the pixel below it, that is at this location. Then once it's gotten those pixels, what we need to do is get the averages of the reds, the greens, and the blues of all of those pixels. So to do that, I did an accumulator pattern. So here's me initializing my accumulator variables. I don't know if I covered this with all of you, but if you're initializing a bunch of variables all at once, you can initialize them like this, where you do the variable names separated by commas, and then the values separated by commas here. So this is saying set red, green, and blue to 0, 0, and 0. Not something you want to do all the time because it sometimes makes your code less explicit, and it won't be something that you'll be able to do when we move on to other languages that are more strongly typed. But for Python, it's okay to do this, and in other languages, it'll be okay to also initialize multiple variables of the same type at once. So that's what I'm doing here. These are just setting up 3 accumulating variables, red, green, and blue. And then I iterate through the 4 pixels, and I did that by doing a for loop and creating a list here of my 4 pixels. So for each pixel in the list that includes pixel left, pixel right, pixel up, and pixel down, I go through and I accumulate the red value, the green value and the blue value of each of those pixels. So essentially I'm creating a total value of red, a total value of green, and a total value of blue of all those pixels added together. And then I create a new pixel using those averages. So I make a new pixel by calling image.pixel and giving it red divided by 4, so the average of red, the average of green, and the average of blue for the red, green, and blue values. And then on my new smooth image, I set the pixel at column row, which is the pixel that is in the middle of the 4 pixels that I'm looking at, equal to this new pixel, which fulfills this requirement. It does exactly what this asks, which is replacing each pixel, which is what we're doing, with the average values of the 4 pixels around it. And so what we end up with is and then obviously at the bottom I return the image, and then this stuff down below is basically the same thing. And so what we end up with is a slightly smoother version of this image up above here. So whereas this is like the kind of blockier version, this version down below is a kind of smoothed out version, which ends up looking like honestly a little blurry, and it's not a very good resizing technique. So not the same kind of resizing technique that you would get in like modern image editing software, but as a basic resize smooth, this works. Now for exercise 12 here, the actual function that you would write in order to do what it's asking, which is to replace each pixel with the median values of the pixels surrounding it, is essentially the same thing as what we've done up here, except instead of finding the average of the 4 pixels surrounding it, like I've done here, like I've done all the way back up top here, like I did up here, you would just need to go through and get the medians instead. Now that is easier said than done, because I don't know that we have access in the textbook to the median functions that kind of come with some other Python modules that I don't think we have access to. NumPy, for one, NUMPY, is a module that involves using a bunch of math stuff in order to get medians and stuff like that in Pythons, and more advanced statistics stuff than that. So I don't think that we have that available to us in the textbook. So rather than rewriting all of this, what I was going to do down here is just give you a function here, quickly write a function that should return the median value of a list. So if we give it a list, it should give us a median value. So I'm going to write us a function that does this. So we need a median function. So we're going to define median list, right? So it's going to take a list, sort it, and return the median. So if you don't know what a median is, if it's been too long since you had a statistics class or a math class, the median is if you sort a set of values. So if I have, for example, 1, 2, and 3, it takes the middle value. So 2 being the middle of 1 and 3 is the median. And if it's an even number of items, so for example, if I have 1, 2, 3, and 4, it finds the 2 middle values, which in this case are 2 and 3, and returns the average of those values, which is 2.5. So let's do that. So we're going to take a list, and we're going to sort that list. And we're going to do that by using the sorted function. So list equals sorted list. And then list length is going to be equal to the length of list. And so these are functions that work on lists that we haven't talked about yet. Take me at my word, this function will sort a list, and this function will give you the length of the list. And I just remember that I can't use list as a variable name, so I'm going to instead use what's a good value for this? I'm just going to use my list. I recommend using that if you're going to actually write a function using lists. You should come up with like a better name for it than that. But this is just an example. So my variables are going to be kind of looser than usual. So my list equals sorted version of my list. The list length is equal to the length of my list. And then if whoops, I don't need to indent there. If the list length is less than 1, so if there's no items in the list, you're going to want it to return none, or return a null value, right? And that's just going to ensure that if we pass in a list that's empty, it's going to always return nothing, so that it doesn't break anything. If the list, however, is has an even number, so if list length has an even number of items in it, i.e. if it is equal, or if it is divisible by 2, we're going to return the value of the list that is so we're going to return the average of the middle items of the list. So what that means is we've got to find the middle items of the list. So middle 1 is equal to my list with an index of list length divided by 2 minus 1, and the middle 2 is equal to the value at my list length divided by 2 plus 1. So if it's a list of length 4, middle 1 is equal to 4 divided by 2, which is 2 minus 1, which is 1, so the second value in the list, and 4 divided by 2, which is 2 plus 1, which is 3, i.e. the third value in the list. So we're going to then return the average of that, which is middle 1 divided by middle 2. However, if it is an odd numbered list, we can just return the middle value, which is my list length divided by 2. So I'll take whatever the value is at the middle part of the list. All right, so there you go. That is a function that will give you the median of a list. So if you intend to try to do number 12, which honestly, if you're having trouble with the above exercises, I truly do not recommend. It is going to be very difficult. But if you're feel like you're up for the challenge, here is a median function that you can use to try to accomplish that. Or you can go out and write your own. So good luck. The weekly graded assignment, I think most of you got around to finishing already, which is great. If you haven't, feel free to message me and we'll get it figured out. All right, good luck, folks.